Hi, everyone. I'm Russ Wilcox. I'm CTO here at CoinGenius. Been working in data science and AI for probably the last 12 years now. Specifically came on board to really create robust and scalable deep learning and analytic solutions for our products here at CoinGenius. Right now, we're working on a variety of interesting products such as live sentiment as a service, in addition to one of my big research areas right now that I'm particularly interested in is blending both deep neural networks and deep learning using generative models such as GANs and Boltzmann's machines and blending that with traditional kind of quantitative approaches for financial forecasting, i.e. Markov chain Monte Carlo and nonlinear dynamical methods. So what we're really trying to do here within the data science space at AI is solve the problem of we only have really 2 years of usable data within the crypto space, given the fact that, from 2009 to 2018, the dynamics of the system were so drastically different and not representative of our current state. So a lot of my research going on and some of the products we have going on here is relying heavily on utilizing traditional market assets in addition to really interesting methods with contextual learning for data augmentation.
Hey, Russ, can I ask, can we play a quick game? Can we play a quick data science game?
Sure.
Awesome. On my phone screensaver, you guys can't see this, but this is the architecture of what data science is. This is like all things data science so that I could learn the vocabulary words of like what it is. So Russ, the game I want to play is a 30-second summary of these data science vocabulary words. In 30 seconds, tell me what ensemble means.
So ensemble means that you're using several different mathematical models to feed into the same final output. So depending on what you're trying to look at, you might have 2 different ways of describing a system, both that are equally important. And you want to judge those and weight those either differently or the same, depending on your output problem you're trying to solve. So it just creates a pipeline of multiple models.
Awesome. Next, tell me what a decision tree is.
A decision tree is a kind of a naive approach of optimization for an outcome. So for example, you might take a look, okay, what is the weather going to be today? You might look at the other outputs. So it's more of a computer science approach that allows you to condition on some observable and have some sort of robust output to make a decision on.
Thank you. What is clustering?
Clustering is an unsupervised learning algorithm, which means that there's no labels associated with it. So a typical problem might be classify a cat or a dog, or classify 2 images that are similar. So what happens is that you're trying to group these kind of distinct clusters into something to describe the dynamics of a problem.
Thank you. What is regression?
Regression is take an idea just back to basic high school math where you have points on a line and you're just trying to model that behavior in a continuous sense and you don't have a discrete variable like a cat or a dog.
Thank you. In data science terms, what does deep learning mean?
Deep learning is a subset of machine learning that is dependent on neural networks. So a neural network is a way of just learning different states of a system, and it comes from deep is because within the neural network you have different, more intricate layers going between your input and output as a series instead of one input, one output. You have lots of different little nodes in between them.
Great. And from a data science side, what does a rule system mean?
So a rule system is a way that you're going about trying to define the dynamics of a system. So what types of dynamics follow a certain set of essentially axiomatic logic that allow you to make a final outcome.
Beautiful. And second to last, explain a neural network.
So a neural network is, so this one is going to take a little bit longer than 30 seconds, but think of it as a guess and check. So what happens if you have a dartboard, you throw a dart on a bullseye and you can say, okay, well, this is close. But basically if you're way off, you have to practice, right? You have to practice and get better. And that's what the neural network does. So you're throwing just random kind of inputs and wanting to kind of predict what happens. And then you put that and you say, okay, what does this look like? If it's close to my outcome, I say, I like that. Let's try to get closer to that. If it's not, it re-guesses and you just gradually learn over time so you get your output. Thank you.
And our favorite, explain the word Bayesian.
So Bayesian is a probabilistic way of thinking of statistics. So for a good example is, let's say you believe in, I have some data showing you that I think Bigfoot exists, right? No matter if you don't believe that Bigfoot exists, it doesn't matter how much I show you, data I show you, I will never convince you. So the idea of Bayesian statistics is that you have some sort of prior belief in the system that dictates your outcome.
Thank you.
I was just going to say
Data
all
Science
that.
Jeopardy. I appreciate it, Russ Wilcox.